right, so the first problem was indexing, and you were asked to index the last 3 rows and 4 columns of a matrix A. So if A is a matrix, and you want to access the last 3 rows and the last 4 columns, and it doesn't matter how big the matrix is, you should still be able to index the last 3 rows and the last 4 columns. So to be able to refer to the last column, the last row, you would use end, END. 1 before the last one is end minus 1, and 2 before the last one is end minus 3, and minus 2. So if I want to access these 3 rows, I would have to say end minus 2. Sorry, let me rewrite that. End minus 2 all the way to end, right? So if A has a size 10 by 10, end minus 2 would be 8, end would be 10, and you would go from 8, 9, 10. This would be the vector that end minus 2 all the way to end generates. The common mistake in this problem was to use end minus 3. So instead of minus 2, some of you had end minus 3. That would give you an extra row. It would give you the last 4 rows, okay? So the correct answer was to go from end minus 2 all the way to end. Comma. So I not only want to index the last 3 rows, but I also want to limit the number of columns to the last 4 columns. And that's the same. I just go from end minus 3 to end. Okay? Any questions? All right. So this colon operator just generates a vector. If you have 10 columns, then you would go from 7 to 10. And that gives you 7, 8, 9, 10, which is the last 4 columns. Another common mistake was to assume that this matrix was a 4 by 4 matrix. So if A is a 4 by 4 matrix, then the last 3 rows and the last 4 columns would be like this, 1 to 4. So, but this would only work if the size of the matrix is 4 by 4. It would not work for other sized matrices. So this was not a correct answer. All right. The next question is asking you to linearly index a matrix that has 7 rows and 5 columns. So matrix M has 7 rows and 5 columns, and we want to access M 4, 3 using a single number mx. And you are asked what this single number x is. So when you do linear indexing, you do MATLAB stores things column-wise. So you would start counting all the way in the first column, starting from 1 all the way to 7. And then the next number is going to start from the second column. It will be 8 to 14. Okay? And the next column will start from 15, 16, 17, and so on. Actually, let's do 18, 19. And you are asked to index the 4th row and the 3rd column. So that will give you 19. Sorry, 18. Okay? Another way to calculate this number is as follows. So we want to find M43. If you look at the number of columns, determine how many times you would jump to another column, right? So you would have this many minus 1 full columns that you have to travel. So you have 2 of them. So this is 3 minus 1 full columns. So you would multiply the number of columns minus 1 times the number of rows you have, in this case 7. So I'll get 3 minus 1 times 7. and then plus whatever the number of columns I have, because at the last column I have to move down to that row. This is the element I need. Sorry, this needs to be small r. Plus 4. And I get 14 plus 4, which is 18. Okay? Next question, using linspace to generate numbers from 32 all the way down to 4, using both linspace and colon operator. So we'll go from 32 all the way to 4, and the step size is 7, 25, 18, 11, 4. So each step size is 7. Using the colon operator, you would do 32, and each time you would subtract -7. You would the step size is -7. If you did +7, that would not be correct. All the way down to 4. So this is the answer for the first part. X equals. The second part is asking me to use a linspace function. For linspace, you provide the first number and the second number and the number of numbers, which is 5. Okay. So if I did, instead of 32 minus 7, 4, if I did 32 colon 7, 4, what would this vector generate? Any answers? It would generate an empty vector, right? There are no numbers in between. 32, 7, 4. You get an empty matrix. There's no number in this range going from 32, going up by 7, all the way to 4. All right? Make sense? Yes. All right. Next question is asking you to do logical indexing. This was probably the trickiest written question in the exam. And we will first construct a logical matrix I that has the same size as M and has truths only for odd elements of M. So we have a matrix M, and we want to construct a logical matrix I that has odd elements of M. How do I specify whether an element is odd? I would have to divide it by 2. Mod M2 equal 1. That would give me whether an element in M is odd. All right? So that's the first question. And the next one is asking you to, using this I, change the odd elements of M by squaring them. So you would just do Mi dot square. So what this would generate, it would generate a new matrix that contains only the odd elements of M. So if your original matrix is 10 by 10, but only one element is odd, then Mi will only refer to this odd element. So effectively, this squares only one element out of your matrix. If you say M equals that, then that would be incorrect. You would be trying to take only the odd elements and store them in the entire matrix. And MATLAB would give you an error saying that the right-hand side and the left-hand side do not have the same number of elements. So what you need to do is you need to index the left-hand side of the equation also. So you would have to say Mi equals Mi squared. So I'm taking the elements on the right-hand side and only referring to odd elements on the left-hand side and storing the result of the right-hand side into the left-hand side. Okay? Another way to solve this problem, if you really wanted to keep M equals on the left-hand side, would be to square the odd elements and not change the even elements of your matrix. Okay, so one way of doing that would be, let me think about this. So you want to construct a matrix that has So we already have a matrix that has zeros where you have even elements and ones where you have odd elements. All right. Actually, it's going to be mathematically too intricate that it's not worth doing it now. So I'm going to skip that part. And I'll try it in the recess. Okay, let's keep moving on for the sake of time. In the next question, you're asked to change the even elements of m by dividing them with 2, so that's trivial. You would just do m not I equals m not I divided by 2. So when you have not I, you are basically switching all of the elements in I. If they are 1, if they are 0, they become 1. So effectively, you are indexing the even elements in your matrix. You are calculating the even elements divided by 2, and you are storing them in the same place. Okay? So a lot of you missed this indexing on the left-hand side, and I did not cut off any points for that, since the way that the answer was set up was sort of misleading. Okay? All right, next question is asking you to trace a function call and figure out what the result will be. So let's write this function in MATLAB. Edit apple. All right. So x equals 5, y equals 6, and then we will call the function apple, y equals apple x. So what happens now is you have to keep track of what's in the boxes. We have and you have to keep track of which box is in which room. X and y are defined in the command window workspace. The function itself has its own separate workspace. So all the variables named A and B in the function workspace are not the same variables in the command window. The only relationship they have is when you call a function, the value of the input argument gets copied into the input argument of the function. Okay? So let me actually draw that in here. All right, not working. Function A equals apple B, and then B equals B minus 2, A equals B plus 10. And then X equals 5, Y equals 6. Y equals apple x. All right, so I have a box x, I have a box y, and then as soon as you call this function apple, the value of x gets copied into the variable b that the function has. So b will now contain 5. A is empty, not defined yet, and then you subtract 2 from the value of b, b becomes 3. And then you take this value, add 10 to it, and put it into A. So A becomes 13. When you get back from the function, you take this output value A, return it in the assignment, and that gets into the variable Y. So Y changes to become 13. Okay? So when you do a function call, all the input arguments get copied into the function variable when you are done with the function, all the output variables get returned and saved into the left-hand side of the equation that you are using when you do your function call. All right, so x is equal 5, y equals 13. Inside the function, the last time you called it, a was 3, a was 13, but as soon as the function is done, these variables get destroyed. All right, so the next set of lines, set a equals 2, b equals 3, a equals 2, b equals 3, and these are in the command window workspace. And then we call the function with b equals apple a. So when I make this function call, the value of a equals 2 gets copied into the b variable of the function. So I have my variable b and a, and b becomes 2 inside the function. This variable b inside the function is not the same as the variable b in the current workspace. So you might as well change all the references in the function with a different name to avoid confusion. So one way to solve this problem, to make it easier for you, would be to replace all the b's inside the function with, let's say, bb, and all the a's with aa. They'll help you keep track of things easier. All right, and then we subtract 2 from the value of b. It becomes 0. We add 10 to it and put it into AA. It becomes 10. When the function is done, the value of AA gets returned, and we place that into the variable b. So now the value of b becomes 10. And then when we print them, starting from x, y, and then a and b, we would print x equals 5. Let me make up some room here. X equals 5, y equals 13, a equals 2, b equals 10. Okay, so these are going to be the values printed. Any questions? All right, next question is a nested for loop. I think a lot of you got this, very few of you got this problem correct. So let's go over it in MATLAB. Edit for loop example. All right, so we have two for loops, nested for loops. One of them is using the variable a, and it goes over values of 3 and 5. And the inner for loop goes through values of b, and those contain 2, 4, 8. All right. Give me an So the first time you enter the for loop, the value of a will be 3. I'm inside the for loop. The value of a is still 3. And then I'm in the inner for loop. The value of b is 2. And I take the value of b, put it at the end of x. X was empty. After this statement, it will contain the value of b, which is 2. Okay? And in the next statement, I take the value of a, which is 3, placed at the end of x. So x will now contain 2 and 3. And you can watch that happening in the workspace window. The inner for loop will keep executing. for the next value of b. Now the value of b is 4, which is the next value in the inner for loop. But the value of a has not changed since I have not gone on to the next value of a yet. I'm still looping around in the inner loop. Okay? So I had 4, 3. Sorry, I had 2, 3. Now I'm going to store 4 and the value of a, which still contains 3 in the variable x. So far I have 2, 3, 4, 3 in the variable x. And then I move on to the next value of b, store that in x. 8 now contains 8 at the end. Sorry, b contains 8 at the end. And I place 3 at the end also. So it goes 2, 3, 4, 3, 8, 3. Now the inner for loop is done. I've visited all of the values of b. The outer for loop will execute for the next value of a, which is 5. And the inner for loop is executed again for the values of 2, 4, 8. So I'll add 2, 5, 4, 5, 8, 5. And then the outer inner loop is done and the outer loop is done. So as a result, I will get 2, 3, 4, 3, 8, 3, 2, 5, 4, 5, 8, 5. Okay? Any questions? All right, the next problem is, we covered it in class. When the value of x is 0, you will first evaluate the first less than sign, which will give you true, meaning 1. So minus 1 less than 0 is going to give you 1. And then 1 less than 1 is going to give you false. And when you display that, you'll get a 0. Okay? The next question is operator precedence. You first apply the arithmetic operations. So remember, it was arithmetic, and then logical. Sorry, and then relational, and then logical operations. Okay. So 2 plus 5 is 7. 3 less than 7 is 2. And when you display that, you'll get a 1. So the answer for this question was 1. Next problem is binary number conversion to convert number 41 into binary format. So you need to figure out the largest exponent of 2 that's less than 41, and that is 32. And that's equal to 2 to the 5. Okay? So this is going to be my binary number, starting from 2 to the 0, 2 to the 1, 2 to 3, 4, 5, 4, 32, 16, 8, 4, 2, 1. So I have at 32 in my 41, so I'll put a 1 at the 32 location. And I have covered up 32. I have 9 left. And I'll repeat the same process with this 9 number. The largest exponent of 2 is 2 to the 3, which is 8. So I'll put a 1 there. And then subtract that from my number. And I'll get 1. And that's going to be placed in the 2 to the 0, which is 1. And the rest are 0. Okay, so this is the answer for this problem. 1, 0, 1, 0, 0, 1. And then to confirm your answer, you can go backwards and add up 1 plus 8 plus 32. Okay? All right, programming questions. The first one is very similar to the homeworks that we did. Edit is divisible by... actually, let me go into a different directory first. Are we in week 7? Okay. All right, function is divisible by, it's not returning anything, we'll just print out is divisible by. So if you are not returning anything, you should not really say y equals, okay? You should not have any output arguments if you are not going to assign anything to them. And we'll take a number x and a number n, and we'll print whether it's divisible by n or not. So we would say if mod x divided by n equals 0, then we would say yes, x is divisible by n. And we'll just take those numbers and replace them with %d. And the first %d is for x, the second one is for n. And if that's not true, then we would just print, no, it's not divisible by n. Okay? 5.2, no, we forgot the new lines. Let's try again. All right? Any questions? Okay, this one was probably the simplest one. Next problem is asking you to write a vectorized code to calculate the Wallace pi. If you did for loops, that's okay too, so long as it works. Function Wallace pi. So this one will take a number n, and it'll calculate this expression. So if you look at the top numbers, they start from 2, go all the way to n. Okay? So I have a number 2 starting from 2, step 2, going all the way to n. That's going to give me the top of this equation, denominator. Okay? And the bottom part is going to be 1 again, step size 2, going all the way. Sorry, let me think about that again. It's going to be n minus 1 and then n plus 1. So let's set this to be x. So x minus 1 is going to be the first portion, which is 1, 3, 5, 7, and so on. All right, let me write that in 1 to n minus 1. That's going to give you 1, 3, 5, 7, and so on, and the other one is 3 all the way to n plus 1. That's going to give you the other term. So I have all these parts. Now I need to combine them. Let's combine them using dot notation, and they should have equal numbers. So let's just square this dot squared, since it's going to be the same, divided by that dot multiply the next one, and we need to do dot division and close this whole thing in parentheses. Okay, so this is going to give you a vector. Let's try it here. N equals 6, and you do that, you get those numbers. They'll give you a vector that you need to take the product of. So you need to multiply all these numbers, since you are multiplying them right here. You can write a for loop, or you can just use the prod function to multiply them all together. Prod is very similar to sum. Instead of taking the sum, you just take the product. That's going to give you the right-hand side of this equation. To get an approximation for pi, you just multiply it by 2. And you should have your result. And the output should be returned, since we are displaying the result of this function call. Let's say y equals that, and y equals that. Let's try to run it. Wallace pi 2, 4, 6, 100, and we should be getting close to the value of pi. Okay? Any questions? All right, the next problem is asking us to get a fancy x where the diagonals are x's. Edit. Get fancy x. Since we are not really printing anything, we need to return the result. As you can see from this function call, the function gets called and the result is displayed by MATLAB. So by saying ans equals, that means the function is returning something. You are not really printing anything inside your function. Okay? Function s equals get fancy x. And it's going to be a square matrix with R. What I can do is first fill up this matrix with periods using the repmat function. So I will just take the period and replicate it R times R rows, R columns. Okay? So what that will give me is a rectangle, dots. I don't think I saved this. Or get fancy x. Okay. Now I need to take this matrix and replace all the diagonals with the letter x. What I can do that by is there are several ways of doing it. One way is to write a for loop. Okay. The other is to use the I function, if you are familiar with the I function. So I of 5 is going to give you a matrix that has ones on the diagonal. Okay. And then if you flip that, left, right, or up, down, doesn't matter. That's going to give you the other diagonal. Take I of R plus flip left, right, I of R. That's going to give me a matrix with diagonals having 1. Let's try it with R equals 5, F9, and you have a 2 here, but that's not a big issue because we are going to wrap it with logical to convert this numerical matrix into a logical matrix that has truths on the diagonals and falses everywhere else. All right? So once I have this logical matrix, I can use it to refer to elements of S, so I can change them. So let's assign this to I, and then I would say Si equals X. And that completes the problem. Get fancy X 5, 7, 9, and so on. Okay? All right. Let me just quickly go over the for loop solution. You could do for I equals 1 to R, and then for j equals 1 to R again. And then you can say if I equals j, that means you are on a diagonal, right? So on the diagonal, the value of I and j will be the same. Then I would replace that with an x. That will only give me the first diagonal. To get the second diagonal, I need another if statement. Else if I equals is it R minus j? Sorry, R equals R minus j plus 1, since the values start from 1. Okay? So you just write a for loop, nested for loop, and if you are on any of the elements that are on the diagonal, you will either be I equals j on the first diagonal, and on the second diagonal, you will have I equals R minus j plus 1, and you get your x. Any questions?